Hi, gentlemen. Student has asked me to look at exercise 5G, number 13, as you see on the screen. So it's always important to read the question and understand the scenario, especially when there are practical applications. So, it's all stated pretty much in the first sentence. After the water boils in an electric kettle. So imagine a picture of an electric kettle. You've got some water in there. Okay, there's the cord. So when the water boils, you need to know that it boils at 100 degrees Celsius. Um, the temperature of the water after m-minutes follows the relationship. So after it's boiled, we switch off the kettle. We obviously will find that the temperature will change. Obviously, based on this, it's got a function. So obviously, we want to be able to draw that function and use it to answer questions like what's the temperature after 10 minutes and so forth. So let's have a look at what is asked us. So part A, which is the independent and dependent variable? So I know it doesn't get very often stated, but you should know that we always go y versus x on our Cartesian plane. And that is because when you look at a function like y equals 2x, the y depends on what the x value is. So if we have a function like that, there's your value x, you go across. And so we always say that the y is the dependent and x is the independent. So the horizontal axis is the independent and the vertical is dependent. And so looking at the relationship given us, T equals the temperature. Obviously, think about it. What? Does the temperature depend on the time after, or does the time depend on the temperature? And we know that obviously the temperature depends on it. So we have this relationship. Now, of course, they've used T and M. So the Y is actual fact the T and the X is actually the M. So we could write it as y equals 20 plus 80 times 0.8, and here is the interesting thing, to the power of x. So you should now recognize that that is, in actual fact, exponential function. All right, so question part B says, what is the initial temperature of the water? In other words, we could easily say 100 degrees, but let's double check. The initial temperature, part B, of course, is when time, that's little t, is equal to 0 minutes, or in this case, if we say x, 0 minutes. So substituting, I'll use the original one so you can see how it works. 20 plus 80 times 0.8 to the power of 0. Now we know 0.8 to the power of 0 is 1, so that's 8 times 1 plus the 20, and sure enough, our 100 degrees Celsius is confirmed. The next question is, what is the temperature of the water after 3 minutes? Okay, so part C, again, we've got T equals, okay, well, T is a function of M, T equals 3, which is equal to 20 plus 80 times 0.8 to the power of 3. Um, Now you'll need your calculator for this because you're going to need to know 0.8 times 0.8 times 0.8. Remember, it's instruction. Alternatively, if you had read the whole question, you will notice that the last statement says use your calculator. So if I assume that we've got access to a calculator, we might as well use it. So we're going to 2 for graphs, and we were going to write in the function. So we're using you could use f of x equals the 20 So it's f of x equals 20 equals try 20 plus 80 times it by 80. No, sorry, apologize. 0.8 raised to the power x. Press enter and you see nothing. And that's because, remember, this is a practical application. Our scale of our Cartesian plane may not suit. So always opt for the menu, Windows settings, for. Look, if you can learn to control it yourself, it's always better. So the best option is menu, Windows, zoom, and go for option 1 where you control the settings. So where do you want the x-axis to start? Well, we know its time starts at 0, but we want to see the y-axis. So I'll say time at -1 minute. And maybe, I'm not too sure how far, but let's say in practical terms, I want to know what the temperature of the kettle is after half an hour. So we'll make that 30 minutes. And we'll do in steps of, say, 1 on the axes. So that's the x scale. Now the y scale, the dependent, that's why we asked that question, is of course the temperature. And we know that the temperature, well, do 0. But the maximum temperature should be 100, but we'll just do a little bit extra. So make that 110, and maybe go in steps of 10 on the scale. And oops, and press OK. Oops, OK. And there's your function. While I've got that, I might as well grab that. Oh. So there is the function. And as you can see, there is an asymptote. What do you reckon the asymptote might be? Remember, as the temperature of the kettle slowly gets, it reaches, or will it ever get to -10, 20, 0? No, it obviously will go to, and maybe that's what you need to look at. Look at the function there. There's your k, which is your asymptote. So I can quickly add an asymptote there, because remember, exponential have one horizontal asymptote, so you look for it. In this case, it's there. So we go Control G for the function, and it's equal to 20. Press enter, and there we have it. We can now do menu trace, try again, and you can trace, go up and down the scale. But notice the steps aren't really handy for us. So we're going to change that. Go back to trace and do the trace step at steps of 1. And you can now go up the axis and we'll go to 0. Remember, we worked out it was 100 degrees Celsius. So when time is 0, temperature is 100. The next question was, what is it at 3 minutes? And the answer is 61. So we can now go down here and write 61 degrees Celsius. Part C is how many minutes correct to 1 decimal place does it take for the temperature to get half the initial? Well, this is obviously assuming you know what the initial temperature was. So based on our answer of 100, they want us to get down to 50. If you accidentally said 80, we would expect you to go for 40. So moving down the cursor, we're trying to go to 50. So there's 52.8, oh, and then 46. So it's somewhere between 4 minutes and 5 minutes. So we can now ask it to go at, say, 4.5, but it's a quicker way. Rather than changing the steps, just type 4.5, and it will say, we will map the X value of 4.5 on there, and we get 49.3. All right, so that was too far below 50, so maybe go 4.3. And that's 50.6. So obviously in between that is 4.4. Press enter, and there's our 50 degrees C. We can press the enter button, so we leave that. And that in some way shows you the dilation factor. Okay, so for part D, we used our calculator. It takes 4.4 minutes to reach 50 degrees Celsius. Clearly, what we have from the graph is you can see that as time goes by, the temperature gets less. And so instead of growing in value, it decays in value. So we call this a decay function. And the reason is because that base is 0.8. In other words, when it's less than 1, it gets smaller. Finally, we need two more pieces of information. That's the domain and range, and it asks you to use your calculator. So remember, using our calculator, we have the two features, where it cuts, where the asymptote is, and where it cuts the y-axis when x equals 0. And we now want to sketch that. Don't forget to put the axes, temp and time, minutes, and you'll have a sketched, or as in this case, a graph on the calculator. And finally, we are asked to work out the domain and range. So remember, I had a video on the domain from the American. He's on the range, and he would have told you the domain is all the x values, and the range is the y values. So the x values, all right, remember looking at the function, obviously it's any value greater than or equal to 0, because the time starts after the water has boiled, and it could go on forever. Another option is sort of in set notation, is x is a subset of r, real, but positive numbers only. So real numbers, positive. The y value is a slightly different case. In other words, based on this, we start at 100 degrees Celsius, because once it reaches boiling point temperature, it can't go any higher, it just evaporates. So it's 100 is the highest, and it slowly approaches 20, but will it ever get there? The answer is no, because it's an asymptote. It only ever approaches. So we can say y is going to be less than or equal to 100 degrees Celsius. So it's in between 100 and 20. So we write between 20 and 100. And remember, it can only be greater than, never equal to. And in set notation, remember, for greater than, we use round brackets, and that's 20. And for equal to, we use square brackets, that's 100. So I hope that helps the student who asked for it, and of course, everybody else for that matter. So have yourself a great day. Cheers. Oh, what happened to my control? I've lost my control. Sorry about this, guys. I'm trying to turn it off. Oh, there it is.